Thank you.
All right. Hi, everyone. My name is Calvin, and I was working with Dr. Yusun from California Polytechnic Pomona University. And our research is called Generative Approach to the Automation of Artificial Intelligence Applications. All right. So machine learning and artificial intelligence throughout the last few decades have been growing in interest. So seeing this chart, we start from June 10th all the way to March 2020, we see this rise of relative search interest for machine learning, data science, deep learning, and all these terms. And we also see the rise of these new applications for artificial intelligence machine learning, like object detection for traffic systems or facial recognition systems, or even medical imaging. So there's so many new applications, and this kind of gives rise to a question on how we can help domain experts, more specifically people who don't really have too much experience in code, but still do want to utilize machine learning inside their research to actually use machine learning, more specifically image classification inside their projects to build something meaningful. So yeah, so the challenge you want to tackle is the steep learning curve of utilizing image classification. So domain experts who do wish to utilize image classification inside their research projects have a very long way to go. So they need to understand how to write a programming language and how to utilize libraries. They need to learn the relatively difficult code required to create image classification models. They need to learn how data is being used in the process and how to compile the data to fit the requirements of the model. And they need to understand how to train, use, and interpret various models to fit their own goals. So taking a look at this screenshot I have of a Google Colab, to someone with more experience in machine learning, it isn't as intimidating, but for those who don't, it definitely looks like something that is complicated and something that most people who really don't have experience in code would like to see. And furthermore, as I discussed about the data, when trying to train your model, you need to compile a data set in order for you to actually customize your image classification model. And that can also be a really big hassle, forcing you to get the data by yourself and then putting it into your computer and then organizing it in a way that fits the model's requirements. And so here is an example of a customization approach, which is very general. So in this case, I'm showing you how we can actually partition all the data. So in this model, we can call it flower photos for, there are different labels. So the labels include daisies, dandelions, roses, soccer, sunflowers, tulips. So I know soccer is a little bit out of touch here, but everything else, the overall theme in general, the idea is just for every single label, you're providing a bunch of images to those labels in order for you to customize your image classification model in a way that's able to identify exactly what type of label your image you provide is. So in this case, notice how in the soccer label, we're providing a bunch of different images, and we're going to have to do the exact same thing for every single one of these labels. And so if we're compiling so much data and we also need to organize it into labels, this process also becomes extremely tedious as well. And the whole goal is for us to make it so that image classification in general is a very easy thing, very easy and intuitive thing for people who want to utilize machine learning to use. So soccer is just one of them. We have to populate the rest of them as well. And over here, they also need to know how to manipulate the code a little bit. So instead of all of this stuff over here, which I commented out, we would have to unzip the folder of flower photos and then rechange the image path into this flower photos in order for us to actually utilize this new data set. And we have to run through the code over again in order to finally get our model. And so after that, we also need to train it. And so here's a screenshot of the training. So they also need to understand a little bit about what's going on here. So as you guys all can see, the general process for someone who really doesn't know how to program, or someone who really doesn't know how to utilize machine learning when making their project becomes extremely difficult. It's just not a very easy and intuitive approach to use. And so that is why our approach is trying to emphasize simplicity. So how do we make it so that the process of creating and using an image classification model is extremely easy? By using a mobile device. So using a phone, all a user really needs to do is take the pictures, and our application will be able to train the model without any organization of images and labels needed. So like I said before, they would have to compile all these images and they would have to put them inside their respective folders. In our approach, all the user needs to do is just snap some pictures with their phone, and it will automatically organize them in a way that fits the model's requirements. And it's also an easy to understand process with an intuitive UI design that isn't overly complicated. So many very similar tools would also have UI designs that are very complicated, and still a lot of concepts that they still need to understand and still need to know. And in some cases, they would still have to be able to write code. But for us, for our approach, there's not a single line of code needed to actually train and use and test the model. You can also export the model trained on the phone. We can easily test the model without a single line of code. We can easily give your model and your labels names however you like. And there's really no need to understand relatively challenging concepts in machine learning or image classification. All they really need to do is understand like the general flow of how everything works, and they should be able to build their own model, customize their own image classification model, and then actually test it using the images that they can snap and do whatever they want with the model, even export it. So the first benefit is easier for domain experts to use. So because we require no code experience is required, they don't have to spend a lot of time learning the concepts of how to program or the concepts in machine learning and image classification. It's also very easy to navigate. The UI is very easy and intuitive, so it's easy to work with. And it's also really easy to customize their own data set. So the model is also more in line with their goals and what they want to do. And because they're using a smartphone, it's very accessible for researchers and other domain experts to use. The second benefit is that it helps lower the learning curve. So our application is easier for younger students and less experienced programmers to grasp and play around with. So it allows them to kind of learn the structure and the general flow of image classification more easily, because as the approach I've shown here shows, it's really, really challenging for somebody with no experience to kind of get it first try. So our application kind of smooths it in, kind of transitions them into the world of machine learning a little bit better, because there's really no code involved, and the general idea is still somewhat similar, but there's nothing really overly complicated with our application. And also this will help with more interest in exploring machine learning and deep learning. Less intimidating thresholds could potentially lead more people to become interested in exploring the concepts further, as the first thing they will not see is like very complex code and different terms like convolutional neural networks or epoch. And there are also fun applications to our program, because when you're taking pictures of yourself and making your own models, you can just have fun with it. You can take silly pictures of yourself like I'm going to show later, and then you can make a model based on that. And therefore, this allows more people to become interested in expanding their knowledge, because they can interact and just have fun with our approach, rather than just get sucked into something that is relatively challenging and something that is not as easy to grasp and understand in the beginning. All right, so here's the app process. So we have a main menu here. And so there are two places you can go to. So you can either build a model or you can test the model. So when you decide to build a model, you go up here. Let me see. Let me try annotating. So over here, here's the building model area. And so you're given the ability to either add in a new model ID, which is the name of your model, or just select an already existing model. So you can name the model whatever you want. You can make an image classification model for flowers. You can name it flower classification. It doesn't really matter. But the moment you create one, you're given one of these bars here, and these bars include both a trash can and a share. So the trash can, how it works is if you click on the trash can, then it'll just delete the model. So if you want to just remove a model from previous existing models, then you can click the trash can and it goes away. The share will only work once you actually train and download the model. So how the share works is that once you click the share, you're given the link, and this link includes the tflight file for the model as well as the txt file for the labels. And you can just go ahead and send that either to your email or text message. And essentially what happens is that you're able to actually use this model now for any purpose that you so wish. And if you choose one of these models, now you go over to the label area. So now you can go ahead and customize your labels and add different pictures for each label. So for example, you can add the name for a label, and then you can click add label, and now you've got different labels you can choose. So for example, we've got an orange label, we got a yellow ball, we got a red ball, we got a green ball for the basketball model. And so for every single label, the goal of you is to take pictures for each of them, take a lot of pictures for each of them. And so you can populate them with more and more images for each. So for the orange ball, you take a bunch of pictures of orange balls. For the yellow ball, you take a bunch of pictures for the yellow ball. And you continuously do this until you get a lot of images. The more images, the better, because the more images you have, the more accurate the model will be. Once you're satisfied with the amount of pictures you take, you click on the training. And what this does is it initiates a training phase where it takes all the images that you've given the app and creates a model. And so after you create the model, you can go all the way back here to the selection page, which went by when you click on test models. And what happens is now you get to choose a model. So whatever model you choose, you have to choose one that actually is trained. So if you haven't trained a model, it will stop you from actually choosing it. So you need to choose a model that is actually trained. So basketball is trained. So once you click on this one, you're going to be directed to another camera view. And then once you take a picture of whatever view you have, it's going to show you this image right here, an image that you actually snapped, the name of the prediction that the model believes it is, and the confidence rating. So over here, the confidence is like 50-ish%. It's not very high because in this experiment, we did not include as much pictures as we like. So the more pictures you add, the better, in order to make the model a little bit more accurate and more consistent. Okay, so the front end of our app is developed using Flutter because it supports iOS and Android versions of our application. So many of these list views, many of these lists we have, so this one and this one and this one, they're all created using the list view class from Flutter. And so it's used to create the menu page over here, and it's used to, and that holds the page routers to the admin and the consumer pages. So the admin page is how we actually create the model, and the consumer page is testing the models. And so we're actually also using text view classes over here. So we're using a text view class. And so what that does is that it gives the user the ability to just name the model however they want. And once they name it, they can click and add model. And what happens is that this new label, this new model name is now inputted, and now you have a new model with whatever name you want. And the same applies for the labels. Whatever name for the label you want, it will just be there. And hopefully you guys can also notice that everything here, the trash cans are all the same for both the models and the labels, because both of them, we want to give users the ability to actually delete either the models or labels. And the backend is developed using a Python Flask server holding 6 main HTTP APIs. So this is connected to a Firestore database that stores the model names, model labels, and a URL which consists of the label text file and the tflight file of the model after the model was trained. So like I said before, as long as the model is trained, they'll be able to access the model, because if the model isn't trained, there won't be an actual file there to use. And so there's actually 6 HTTP APIs we're using. So one of them is called get all models and get model info. And now what this HTTP API does is it allows us to actually show the different models and labels over here in this list view class. Because what happens is that once they input the model ID, the app basically puts in this new model ID into the Fire database. And so in order to actually access all of them, we would need to get an HTTP request to take in the different model names and the model label, labels that they've specified in the past. And so also we've got an add model and add label. And basically what this does is this accesses Firestore database to insert a new model label. We've also got another HTTP API called train model. And essentially what this does is it just trains the model based on the images provided in the labels and uploads model files into the database. We've also got upload image, which saves pictures taken by the user and stores the files to the database under its label. And so here's an example of the get model info and get model that I was talking about. In this case, this HTTP API get model info returns a dictionary. And as long as we supply the name of the model, we're able to get a complete list of the different labels specific to that actual model. And for get all models, that one is okay because that one will just return the list that we want, the list of all the models that the user has inputted in the past. All right, and here's an example of the API being used, the http.get request over here of the add model. So in this case, what's happening is that we're using the model ID controller, which is basically the text that the user puts in over at the model ID text field. And so what it does is it adds this text to the database. And after it does that, it loads the models again and sets the state. And now we can see this new change over at the front end. And so here's an example of the database we're using. So over here, we've got basketball, cool cars, room, trombones, vegetation. We've got different models in this section. And for each model, we've got different fields. So we've got labels, but we've also got this URL that I was talking about. This URL contains all the txt file and the tflight file of the actual model. So this URL right here, and this will only pop up if you train the model in its entirety. And here is the storage. So in this case, we're looking at the yellow balls. So these would all just be images of the yellow ball supplied to the label. All right, and here is like a quick demo of how the app actually works. So the first thing you would do is supply them with the name of your model. So let's call this face detector. And so once you put in face detector, you can go ahead and click add model. And now you would have a new model called face detector here. And again, you have the ability to erase it if you want and share it only unless you actually train the model. And so now you've got the ability to actually supply it some labels. So in this case, for the face detector, we can have a label for happy, we can have a label for angry, and we can also have a label for sleepy. And so for every single one of them, the goal is to supply them with images of someone who's really happy, and an image of someone who's angry, an image of someone who's sleepy. And then once you supplied with them enough pictures, then you would click on the training. And what that does is that it will take all the images that you supply and it will actually formulate a model. So here's a picture of happy guy, and then here's a picture of angry and sleepy. So again, here's an example of the sleepy, of the angry being put inside the database, put inside the storage for that specific model. And so after you're comfortable with how many images that you put in, you can go ahead and for every single label, just put in the images, and now you click training. So after you click training, then it will start to train. As you can see over here, it's training the model. Of course, the accuracy won't be very high because we've only supplied 20 to 30 images for each label. Generally, you would just want a little bit more in order to get a more consistent and strong model. All right, and so here are the actual consumer pages. So right now, what we've done is we've selected the model face detector. So we've got multiple models we could use, but for this case, we're just choosing the face detector model. So over here, we can take a picture of yourself happy. And now once you supply it with a picture of yourself happy, then it can actually predict what type of label it is. So in this case, because the model detected that I was happy over here, they said I was happy, and they give you a confidence rating of 47%. So of course, as long as you supply more images, the confidence would probably rise, and the consistency of which the model is correct would also rise. So here are video demos. I do not think I have enough time to show the longer or shorter versions, but if you guys are interested, you can always email me. I'll show my email in the end of the presentation. So here's the completeness of our approach. So we also wanted to discuss how complete our approach was. So how similar was it to like the actual general standard programming approach to creating and customizing an image classification model. So exploring the completeness of our approach, we can see here that we are able to train the model, we're able to make a prediction, we're able to upload a data set, and we can also run multiple programs to create multiple models. And so from training the model to uploading the data set, our mobile application imitates the exact same functionalities as a standard approach with the benefit that is extremely easy to navigate and there's really no code involved at all. Virtually anyone can just use the application and then make a model on their own without having to write a single line of code. We also looked at the accuracy in relativity to the actual amount of labels. So over here, we supplied confidence percentages for 3 labels and 6 labels and 10 labels. So as you can see here, they do not really waver off or anything. They always stay a good, comfortable 85-ish% above. And so the overall accuracy was 100%. And in the median for the confidence percentages was above 90%. So basically the accuracy of the entire thing does not waver the moment you add in more labels. So it works as intended. And so the conclusion is that this application is just a free, easy to use approach to train and utilize custom models. There's really no code needed. It's an easy method of gathering data sets and just imitates the functionality of the standard approach and has a high and consistent accuracy despite increasing numbers of labels per model. It's just an easy way to train, to utilize different models without any lines of code, and virtually any domain expert or anyone interested in using machine learning would be able to use the application. Thank you. That concludes the end of my presentation. If you guys are interested, you can always email me, and I also have my phone number labeled here. Thank you all so much.